Today we're going to talk about the Docksal Stack. Docksal is a tool for creating local development environments for building websites. It's particularly specialized in Drupal websites, but it does support uh, languages and technologies of all sorts. Docksal is similar in purpose to tools you may have used in the past, such as Acquia Dev Desktop, Drupal VM, MAMP, WAMP, or XAMP. The key difference between Docksal and these technologies is that Docksal is all based around the Docker Linux container system. Docker helps you to create, manage, and eventually, when you're ready, destroy uh, many small portable Linux containers and share your container configuration with your team. At the most basic level, what you see here on screen is the architecture of the Docksal system. Uh, Docksal runs inside a virtual machine. For most users, this would mean you're running in something like VirtualBox. Uh, uh, and then all of the Linux containers run inside this virtual machine. If you're natively running Linux, if you're not running Mac or Windows, your actual desktop computer is Linux, then the virtual machine isn't actually called for, but I'm not going to spend a lot of time focusing on that use case in this video. Docksal exchanges files with your host OS, so your Mac or Windows operating system, using NFS shares, that's network file system shares. So when you write some code, that code goes into your Docksal environment using an NFS share, and then it serves web pages like any web server would over an HTTP connection to your browser. Now, if you're just a casual Docksal user, if all you want to do is install Drupal or WordPress and do a little click and drag configuration, maybe you write some CSS, this actually might be a deep enough understanding of the system for your purposes. But this video is intended to be a deep dive, so let's dive in. Under the hood, running inside your virtual machine, are a whole bunch of Linux containers. At an absolute minimum, every Docksal system will have these three: the DNS server, the reverse proxy, which you'll often hear called the vhost proxy. I'm going to call it a reverse proxy throughout this video, and then the SSH agent. These three Linux containers provide a service to every other Docksal project that you might run within your virtual machine. You might only have one Docksal project running on your VM. You might have 50 Docksal projects. No matter how many Docksal projects you use, these three services, the DNS server, the reverse proxy, and the SSH agent, will all be shared. So let me go over in turn how each of them works. First, the DNS server. You may notice when you install Docksal that without needing to modify your local host file, Docksal is capable of receiving requests for all subdomains of the .docksal parent domain. That is to say, and you can see some examples of these here on screen, if you try and navigate to example.docksal or example1.docksal, that request will always be received here by this virtual machine. That's achieved by a DNS server that's actually running inside of your VM. The technology that powers this DNS server is DNS mask, but that's not generally relevant knowledge for Docksal development. So when you install Docksal on your computer, two things happen. The first is there's a modification made to your local DNS system. So if you're on a Mac, you can actually check this out. You'll have a new DNS resolver installed in your etc/resolver directory. This is a lot like if you've ever added the Google public DNS server to deal with some sort of a network outage, the 8888 server. This is similar to that, but because of the nature of this resolver configuration, it's restricted only to impact domains that end with the .docksal top level domain. Now this on its own is actually not enough to cause your computer to resolve websites on the Docksal VM. There's another step, and that is the DNS server running inside a Linux container inside your Docksal VM. So the nature of an HTTP request for you once you have Docksal installed is going to involve a DNS lookup on this server. And this server is smart enough that it can respond to DNS lookups that end with the .docksal top level domain by supplying the IP address of the Docksal virtual machine. So if you do a name server lookup for example.docksal, you'll see that the host is 192.168.64.100, which, by the way, is the IP address that's used for all users running the Docksal environment. If you're on Linux, it'll actually be something different. I believe it's a local address, so 127.0.0.1. But this server, if you try and look up the IP address of a URL other than a .docksal URL, will give you the real public IP address that a public DNS server would supply. So this is how this request looks. This is the very first thing that happens when you begin an HTTP connection to your Docksal local development environment. First, your browser checks the DNS server, and the DNS server replies with the IP address 192.168.64.100. That happens to be the IP address where the DNS server itself lives, but that doesn't have to be the case. We could theoretically host this DNS server somewhere else, but we don't. The next thing that happens is your browser will take the IP address that it got from the DNS server, and it'll send an HTTP request. That request is going to be received by the reverse proxy, or the vhost proxy as it's often called. That's an Nginx server which uses Lua script to do the routing. And basically what we're going to look at here inside the reverse proxy container is the host header. The host header, example.docksal, is going to tell us which of our many Docksal development environments we want to connect to. In this case, I've requested example.docksal. There is indeed an example.docksal stack. And in this case, we're going to assume that that stack is running. If it were not running, vhost proxies actually smart enough to wake it up, to start it up when a request comes in. That's a new-ish feature of Docksal. But for the purposes of this, when a request is received by the reverse proxy, the Nginx reverse proxy, it'll check the domain and forward it along to the final place where this request will be fulfilled, which is the Apache web server. Now, the Apache web server on its own does very, very little. It pretty much just has Apache installed. Everything interesting about this request is going to happen either in the Docker MySQL server or in the Docker CLI. The Docker CLI, critically, is where PHP is installed. So the Docker Apache server is going to communicate with the CLI server using PHP FPM. The CLI server is also where Xdebug is installed, and as well as a wide array of development tools that we'll explore later in this presentation. So from here, the request fulfillment is actually very similar to what you would expect in a conventional system. The Apache server connects to MySQL. You may have Memcache or maybe even Varnish in here, but it connects to the services that it requires in order to fulfill the request, performs whatever database lookups it needs to do, builds out an HTML page, and then finally gives a response, gives an HTML response, which the browser ultimately renders, or perhaps it's a JSON or XML response if you're building some sort of web service. That's what a basic Docksal HTTP request looks like. Now, I'm going to talk a little about the development tools that are available to you when working with the Docksal system. The first and perhaps most important tool that you'll utilize every day you work with Docksal, whether you realize it or not, is NFS shares. NFS shares is a system that stands for Network File System. It's the system that allows files on your host OS, so your Mac or Windows OS, to communicate with all of the systems running inside your Docksal VM. So the Docksal VM mounts your entire users directory. So my name's Matt, so that directory would be ~users/Matt. That entire directory is available inside of the, that entire directory is available inside of the Docksal VM. And then each individual Docker container that requires access to those files will do a sort of a secondary mount using what's called a Docker volume. I'm not going to go too deep into the into what a Docker volume is and how it works, but just know that it is, for most purposes, functionally equivalent to an NFS share. And in this way, all the way, we're now two levels deep here in virtualization, and we're still able to access files that are created on the host OS. One thing to note here is that only the Docker CLI container, where all of your development tools live, is able to modify files. The connection between your host OS and the Apache server is read-only. So that's mostly to minimize the risk that the Apache server might overwrite or in some way damage files on the host OS. The reason that the CLI container has to be writable is so you can do things like download and install Drupal modules, or use the Drupal console tool, for instance, to create new files. Use use Node.js to compile SAS would be another example where the CLI needs to be able to write files. So very basically, the way it works is this: you have a directory on your host OS, your Mac or Windows machine. That directory is inside your home directory, and you're running you have Docksal set up inside of this directory. You create a file in that directory, or you modify a file, and it will instantly be available in both the Docker CLI and the Docker Apache server. So from your perspective, this is a seamless experience. You edit a file locally, and it is as though you were SSH'd into your Docker container and editing the file using Vim or something. But you don't have to do that. Docksal is just sort of smart enough to retrieve those changes instantly. The next aspect of the system that I want to talk about is the SSH agent. So any SSH keys that you have running on that you have installed on your host OS will be either automatically available to all of your Docksal containers, or can be made available through a simple manual configuration. Usually you don't need to do any special configuration. So all of the SSH keys that you have in your home directory can be used to connect to any of your Docksal containers. Also, your Docksal containers can use these keys to communicate with the outside world. So if you have an SSH private key that allows you access to some secure server, your Docker containers will also be able to access that server. This is how most communication is done with your Docksal development environment. Anytime you run a fin command, this is how your host OS will talk to the Docksal VM. And if you run, for instance, fin drush status, this will be how that communication travels. Now, note, when you do something like fin drush status, the actual drush binary is running inside your Docker CLI. It's not equivalent to running drush on a remote server where your local PHP binary is accessed. All we're sending over to Docksal is an SSH command that we're just sending a command that over SSH that we want to run. And taken together, these are all the parts of the Docksal stack.